Good morning. It's really nice to see so many of you here to come to a talk about Go. I hope you all had a great conference so far. It's really been amazing. So it's amazing how the organizers pull off a conference of this scale. I'm really impressed by that as well. And today I'm going to talk a bit about why we're not using Java anymore. So we're using Go for our main product. But let me tell you a bit about our history first. So exactly on this day, 25 years ago, we released the very first version of a hospital application system. Right? We released this in the University Hospital of Leuven. And for a long time, everything was fine. We were using it. The system kept growing. We switched to Java very early on, after using Prolog for a short time. And then this happened. Other hospitals around Belgium started getting interested in this application, and the application kept growing. And so by now, we're actually one of the largest systems in Belgium. And to give you an idea, we are present in about 30 hospitals. So in total, we have 67,000 users, and there are 7,700,000 patients registered into our system. Now, Belgium is a country that has 11 million inhabitants. So we're, close to 80% of the Belgian population is in our system. And all these medical professionals and others that use our system, they generate close to 1 million reports each month. Right? So it's kind of a large system with a lot of throughput. And an idea for the technical side of things, what is running this, right? So after about 25 years, you have a lot of code. Our system has about 38 million lines of code in it. Now, this is just like what I checked on SVN some months ago. Is not pure Java, right? There is some, you'll probably find Prolog in there still, but also XML configuration files, tests that people did not remove. But it gives you an idea of the scale, right? So 38 million. And all of this we are running on just one database. And so we have one active database at any time. I mean, we have backups, right? If something goes wrong, we still have your medical data. That's okay. But we have one active database. It's about 20 terabytes in size, mostly medical data, a lot of sensitive data, of course. And we process 300 million transactions a day. And we're managing these ourselves. Right? We have a Sybase database that we manage. And we release a new version of our program every week. So we're quite agile, especially in the medical field. It goes incredibly fast for us. But it doesn't scale. Right? So at some point, you reach your limit. And we have pretty much reached that limit at this point. So they came to us and they were like, hey, maybe we should start over. We want to scale, we want to keep expanding, but our system is clearly not going to last, for the next 20 years. So we need a solution for this. And so the idea came of building an entire healthcare platform. So we will have general practitioners. Right? Those are the people you go to, like the first line support doctors, right? If you have an illness, you have the flu, you first go to them, hopefully. We have home nurses, so the nurses that actually come to a patient's home. And we still want to keep running in hospitals. So we're going to expand a little bit to basically cover most medical domains in Belgium at some point. And we're building a platform for this, so we could, in theory, support dentists, physiotherapists, and other things. So this comes with a few challenges. Availability is a really important one. We run in a hospital, and a hospital doesn't sleep. If we go down at 4 in the morning, maybe there is an emergency operation. We don't really want to go down during, any time. And we want to keep scaling, right? So Belgium is a start. We're going to expand beyond that possibly. Definitely expand in Belgium, right? We still have 4 million patients that we can get in our system to cover the whole country. And all of this needs to be fast. I mean, it's a really, really large application. At the moment, it's a fat client in Java, but you want things to be fast, right? Nobody likes waiting for a minute to show their report. Even worse when the patient is just sitting with you waiting for that to show up. And security. It's medical data. Medical data is sensitive. Nobody wants their data spread around the internet, for example. So security is, of course, going to be a key point for us. On top of that, the data is also sensitive, privacy sensitive. Right? So since last year or 2 years ago, everything needs to be GDPR compliant. It's just the world that we live in, especially being based in Europe. So we thought about this, and we were like, okay, challenge accepted. We can do this. We can transform a 25-year-old system and make something new. And this is also the ideal time for looking for a new language, right? So if you want to introduce a new language into your system, when the system is 25 years old, it's not that easy, right? We didn't have microservices in the 90s. So basically, if you want to start making a switch, it's going to be a big bang switch, right? You're going to have to make everything from scratch. And that's our idea as well. So this time, we know we want to be scalable, and we're going to run on the cloud. Right? So that's something that we couldn't do in the 90s. That's something we can do today. And we want it to be future-proof. Right? We have a system that's like 25 years old. We hope that our new system will last at least 25 years as well. Right? So we build long-term systems. And whatever language we use, we would need to have a pretty good ecosystem. We don't really like reinventing the wheel anymore. Right? So now we can take advantage of open source projects, and we really want to do this. And it needs to be a cultural fit. We have about 150 Java developers actively developing our application. We want them to be able to use the new language with as little friction as possible. So we had some options. We had Scala, for example, but Scala is a much more, it's a paradigm shift. It's a bit harder to learn, right? We looked at Kotlin and several other languages. But in the end, we settled on Go. And this is hopefully not a surprise, because otherwise I probably wouldn't be standing here. And one of the main reasons we actually didn't opt for another Java language, even though we looked at using Java as well, is that we didn't really want to rely on the JVM anymore. We want to be using a language that's much more focused on the cloud or suitable for the cloud. Do keep in mind that this decision wasn't made yesterday. This decision was made a couple of years ago. And a couple of years ago, Graal was in a much younger stage. Java fibers, well, we didn't even talk about them yet. Right? So even though Java evolved very rapidly lately, it wasn't an option back then. Some buzzwords. If a doctor enters something in our application, it's going to be a web application this time. We don't want to build another fat client. We're going to use Angular on the front end, and then basically the call goes to a Go backend. After that, we talk to a Cloud Spanner database. So that's Google there, Google Cloud Platform database. And we also, every action that happens in our system will go through PubSub. And from PubSub, it will end up in BigQuery. So basically, when you're dealing with this kind of system, there are legal requirements for what people can do and what you need to be able to trace. Every action that happens in our system needs to be traceable. If somebody gave a patient the wrong medication, we need to know who did that, and ideally why they did it. Right? So every single action that happens is logged into BigQuery, but we want to have an up-to-date version in Cloud Spanner, so that we can always rely on Cloud Spanner to be the latest data. So we settled on Go for doing this, and maybe a quick show of hands. Who here thinks Go is less than 5 years old? Okay, no one, great. Less than 10? Okay, quite a few. More than 10? Okay, this month is the 10-year anniversary of Go. Okay, so Go was publicly released in 2009. It was in private development at Google for some time before that, of course. And Go's history actually can trace back all the way to Algol. It has influences from several languages like C and CSP. But it was basically made by Robert Pike, Griesemer, and Thompson. And they made this because, well, the story has it that they were in a talk about C++. And C++ was getting new features again. And they were thinking, okay, C++ is getting incredibly complex, right? It's almost impossible to really understand the entire language, and for other people to read your code because you use a feature they never even heard of. On top of that, they were working at Google, and they were having some problems scaling with C++, mainly the compile times. C++ takes some time to compile, and they didn't like that anymore. So they set out to make a better version of C++. In a way, that is what Go became. So their expectations was, okay, we've made this system that is basically a better version of C++. So who wants to use this? C++ developers. In reality, most people who end up programming in Go, they come from Python or Ruby, right? Quite different languages than C and C++. And there are a few hypotheses of why that is, right? One is that C++ became so complex that when you, as a developer, spend all this time learning C++, you don't want to use a language that has less features, right? Because all these exotic features that you see once in a year, you like them, and you learn to use them. Another thing is that when you're developing with Go, Go kind of feels like a scripting language. It isn't, but it feels like it. In the way that you develop, you have really rapid iteration cycles. You can see your output immediately. The compilation step is basically hidden for you. So it feels like a scripting language, and Python people and Ruby people, they really tend to like that. Because even though it feels like a scripting language, you do suddenly have a compiled, fast language that is type safe. So, some philosophy. This is a really long document, doesn't really matter that much, but I'm going to highlight one part. And this was written in 1964. Right? It says that we should have some ways of coupling programs together like garden hose. You screw in one segment when you need it to massage data in a different way. And this is the way of I/O. This is what Unix pipelines are based on. And so everybody who uses a Unix-based system today probably uses the pipelines to do stuff in your terminal. This is an old idea. It's from 1964. And we can amend to that this is also the way of Go. Go is a rather complex language, but it's built up of really, really small parts. The entire tool chain is built up of really small programs that do one thing. It does one thing really, really well, and you can chain them together to get complex behavior, like the Go compiler. So they set out some goals for the language. Right? They wanted to make this new language, and it shouldn't really surprise you, but one was less is more. They're going to write big programs by big teams, and they want to have minimal programmer effort. So keep in mind, this is a language developed at Google. Google has a lot of developers. They have quite complicated programs. So the easier it is for developers to use your language, the more value you will save as a company. And less is more is basically from the idea that C++ is too bloated or too complicated. We're going to make a version with which you can do the same things, just easier. And that's fine. And then you start thinking about it. What is less? Well, when you come from the Java world, this is less. Right? These are things that every Java developer hopefully knows. You have the constructors, you've got streams, type hierarchies are one of the central things in Java, generics, exceptions, a nice lambda syntax since Java 8. All those things are not there in Go. Right? Go doesn't have any of these things. And that's because Go is a much more simple language than Java. Go tries to be so simple that any developer can read code that he didn't have any contact with beforehand. You pick a file from a colleague and you should be able to understand what's going on. So, as opposed to like C++ where you end up with code that you just can't understand anymore. So we mentioned this to our colleagues who were trying to convince like, hey, Go is a pretty cool language and you should probably start learning it. And this is one of the reactions when we tell them like, hey, generics, that thing? It's gone. Right? Inheritance? Yeah, don't think about it. It won't work. So that's like a slight panic moment for a lot of people, especially the generics. It's a very controversial topic. But what do you get when you're using Go? Right? So Go is still a C-style syntax language. It's not like you have to learn something that looks completely different than what you already know. Right? It is garbage collected, so we don't do manual memory management. That's done for us by the runtime. It's incredibly fast. There's like these quite popular Debian benchmarks. Go beats Java in every single of these benchmarks except one. Right? There is one where Java is, for some reason, incredibly fast and beats Go. It is statically typed. Right? That's nice. And a compiled language. It compiles to native code. Right? So you don't run on a virtual machine. You just run natively on the system. It's very opinionated. There is one way to do things, and if you do things in a different way, Go will scream at you. It will tell you to change what you're doing. You're writing code in the wrong way. Used to say things like, where do you put your curly braces? Well, Go will tell you. And it's object-oriented-ish. So there was a really great talk some days ago about running a JVM on Rust, while building a JVM with Rust. And one of the comments was, yeah, Rust is not really object-oriented, because Rust does not have type hierarchies. You don't have inheritance, and you don't have method overloading. Go doesn't have these things either. Right? So if that's what makes a language object-oriented, yeah, Go is not object-oriented. The idea actually is that Go is object-oriented, but not the way that Java was doing it. Right? So there's an idea of object-oriented programming from Smalltalk and other languages that Go looks at and thinks, hey, that's a good idea, but the way that Java ran with it, or C++ actually ran with it, is maybe not the correct idea. And that's something that when you start reading about Go, you will find more often. Like the Go community has this idea of, if we can implement something in a good way, we add it to the language. If we're not sure about how to implement it in a good way, it doesn't get added. Right? One example is generics. We have a few proposals in now, and they keep getting new proposals for how to add generics. As long as it doesn't fit, it won't get in the language. So there are some differences, but there are at least some similarities as well. And this is a really small Java program that basically does fizzbuzz. And so everybody knows how to write fizzbuzz. It's quite simple. And if you just look at it superficially and you look at the Go version next to it, they look very, very similar. Okay, some parentheses seem to be missing in Go, but I swear it is valid syntax, it will run. And maybe that's one of the painful things about Go when you're learning it. There are very small differences in the syntax between Java and Go. And so it's not even optional. You can't put parentheses around your for loop. It will just not work. It doesn't compile. Right? So when you're learning Go, that's something you will run against. And it's kind of annoying, but at least it's a compile time failure. So not the end of the world. Also the famous semicolon, yeah, we just don't use them. They're not there in Go. So a small hello world program that I think should be able to read, right? So you have a package declaration that's pretty similar as in Java. Then we list our imports, and after that we have a main function that calls another function called greet, and our greet function returns hello devox. So something you will notice here is that the greet function returns a string. So the return type appears after the method name, or the function name in this case. So the order of doing things is a little bit different. And it looks like there's no access modifiers, right? What's happening here? Is this all public or is this all private? Right? It's actually there. The access modifiers are in this piece of code. In Go, when a variable or a function starts with an uppercase letter, it is public. If not, it's private. Right? So takes a bit of time getting used to, but in the end it's less syntactic overhead that you would get from other languages. You will learn to read it quite easily. Of course, you have to keep in mind to capitalize and use lowercase when necessary. But it is actually quite simple after some time. Another thing is that there's no objects or no classes, right? We don't have a main class. It's just a bunch of functions. And that's because you could actually write Go without creating a single class. It's not necessary. Go is a multi-paradigm language, and object-oriented is just one way of doing Go. It's not the only way of doing Go. So if you wanted to, you could write Go in a completely functional way. It's maybe not a recommended way, but it's possible. And lastly, imports in Go, they basically won't work. When you import things from the standard library, you don't need to specify you're importing them from the standard library. And so in Go, it's fummed. In Java, it's java.util.star or whatever you need. So let's dive into some more code about Go. And the idea is you have this function in Java that hopefully takes a string and returns an integer. Java's been some time, so I hope I still got that correct. And we're going to do this for an array list. Right? So in Go, you would have a function that takes a slice of strings, and it returns a tuple. So a tuple is something that's native to Go. Right? You don't have to do something special to get multiple returns. You just return a tuple. It returns a slice of integers and an error. And when I say slice, by the way, you can think of this as an array list. It's not the best comparison, but it's a better comparison than simply saying it's an array. It's a dynamic array, It's actually a view on an array, and it can grow, it can shrink, you can do things with it pretty much as if it's an array list in Java. So it's a close comparison. We're going to range over all of our strings that we get, and we call the string converter, so string conv atoy function. So ASCII to int, and we basically pass our ASCII character to it, and hopefully it returns an integer. But it can also return an error, because we have tuple returns. If there is an error, we're just going to throw it back up the chain, and we will have a partial result. So the return slice will be partially filled in. If nothing goes wrong, we just assign the number to the array, and we keep looping until the end. And then we say, okay, here is this slice of integers, and no error, nil. That's basically what null is in Java. And our calling function can basically call a string to number function. We pass a slice of strings, and we possibly get an error back. When we get an error, we're going to panic. And it's going to say never panic, because panic is a code smell. Panic means I want to stop my application. In Go, you generally don't want to do that. You should handle your errors a bit more gracefully. And then you're going to print it. This is the way you do error handling in Go. Every function that possibly goes wrong looks a bit like this. There is no exceptions. There is no try-catch, right? Something that you write quite frequently in Java. An error is just a variable. There is nothing special about it. Right? You can return it like a normal variable. You can pass it on. You can do whatever you want with it. But that's it. There is no special meaning to the error type. We do have a panic here, and like I said, not the best idea to use. Panic and recovery, you can emulate Java-style exceptions. And that's kind of dangerous, because we all come from Java and we think, okay, we'll just make exceptions and throw them up the stack. Generally, that's not the way it's done in Go. Right? And tools will complain about that. The multiple return you see here, it's an AND tuple. You don't need to just return 2 values. You can return lots of values if you want. You can return 500 of them, and then your colleagues will hate you, but the compiler will not complain. So we do still have classes, right? So you don't have to use them. You can use them if you want to use them. And in our case, we would make a struct. So we have a struct animal, which has 2 fields, a name and an age, and they're string and integers. So mostly in Go, the order of how you write things is reverse of what Java is doing. The type comes after the actual name, but that's just by convention. And in this case, our function takes animal before the argument list, and it returns an integer. And this gives the function a special meaning. At this point, it's saying our animal is a method receiver, and our age function is defined on our type animal. At this point, you've effectively created a class with a method. And you can call this method pretty much like this. You can create a dog instance. So my dog is an animal called Kino, and he's 10 years old. And I can print mydog.age. You don't need to write in this way. But mostly in our code base, everything looks like this. We're all used to working with objects. We're used to working with Java. So the dot syntax to go with methods and objects and classes feels a bit more natural to us. Also, here you have the constructor. The constructor is the thing that says animal, and then the curly braces, Kino and 10. That's how we make objects in Go. And one downside to this, if you come from Java, is that our constructors cannot contain logic. It just can't. It's just a special syntax to create an instance of animal in this case. You could create a function that returns a dog, like you would in C, for example, but by default, there is no constructor behavior. And we can compose these objects. So like I said, there is no type hierarchies, there is no type taxonomy that you're doing when you're developing Go. In Java, everything goes into a structure. Everything has some type of hierarchy. Right? Even when you don't extend anything, you're extending objects. You can't escape the type hierarchies in Java. In Go, you can't express these kind of relationships. You can only use composition, which actually, if you use Java, most of the Java code also uses composition in one way or another in the end. It just turns out that in Go, that's the only way of doing it. So for example, we have a type person, which is a struct, taking a name and an age. And then we have a type doctor. And the doctor takes a person and a string with an ID identifying our doctor. And our person field doesn't have a name, right? So just person. And Go knows that all the fields that belong to person at this point belong to me as well. Right? So you could create a doctor. You could have the first ID, doctor1, and you create a person as well. So at this point, you're creating multiple structs at the same time. You're creating an instance of all these classes, right, in Java terminology. And so we create a doctor whose name is who, and he's 21. And at this point, we can actually print his name by saying doctor.name. But name is not defined on doctor, it's defined on person. And Go will basically do this transparently. You don't have to think about where does name come from. Okay, so name comes from one of the fields that I have. If you want to, you can use a fully qualified path here. You could say doctor.person.name. In general, you don't need to do this. The only exception is if you have a naming conflict. Right? If two of the objects that you're composed of contain the same field name, Go is not going to say, I'm going to randomly pick one and hope it's the best. No, it's going to say, no, sorry, I can't make this decision. You need to make this decision. Which thankfully is a sensible choice, actually. But we do have interfaces. Right? Interfaces are not exactly the same as Java. They tend to be really small. So if you look at the standard library of Go, there's plenty of interfaces that have one function or two functions. The thing is you can compose them. So you can compose functions to create functions with more functionality. And these functions are all implicit. So we never say, hey, I implement the function blah, blah, blah. Go will figure out that your struct implements a certain interface. You don't have to write any code for that. The interfaces, you expose them to the outside world, so other people can make an implementation of your interface if you use GitHub packages or whatever, and then your struct, if it adheres to the interface, can use the open source library. And then I made this comparison, and it's kind of a dangerous comparison. It says that the empty interface in Go is kind of like using an object in Java. And that's not entirely correct, but just like in Java, every object somehow is of the type object, right? So if you have a class person, that still implements or extends object. Well, in Go, every struct you make is the empty interface type. And that's because the empty interface has a really simple contract. It says, if you make a struct and you want it to be of my type, it needs to have 0 or more methods. Everything has 0 or more methods, so everything is the empty interface. So if a function accepts the empty interface, that's the same as accepting object in Java. It's quite useless to do so, but you have some kind of generic function. Of course, you need to start typecasting at that point, and that's maybe not the best way of doing things, but it's possible. And it does happen from time to time in Go. No generics, right? Another thing is that interfaces in Go, even though they're a very central part of the language, the empty interface will not contain any state, like an interface in Java. The object in Java, of course, does contain some state, and you can call some methods on it. In Go, you can't call anything on it. You can only start casting it to other interface types. So as an example, we have this type called printer, which is an interface, and it has a print function, and it returns a string. And now we have a type dog, and he can print his name, and he barks. You can't tell from just this snippet, basically, but dog at this point implements the interface. Right? We just don't write it. The compiler will figure it out for us, which is lovely at some times and kind of annoying at other times. Because what if you refactor the interface? Can your IDE discover which ones are actually implementing the interface and which ones aren't? For a long time, that was one of the main issues when picking up Go. The editors just couldn't handle this kind of stuff. Nowadays, especially the JetBrains IDEs, they can handle this scenario quite well. They can trace back which type belongs to which interface, so you can start refactoring. We have another type, a key generator, that prints a really random string. So both of these are printers. And at this point, we can also create a main function that creates a dog and a key generator, but stores them in a slice called printers. So this is pretty much like what you would get in Java. You can loop over all the printers and you can only call the print function on them. And this is how we structure interfaces in Go. And as I said, they're going to be very small, so you possibly, when you have one struct, you're going to implement 5 different interfaces. That's just normal in Go. And one key point, one thing that made us think like, okay, Go is a good language for us, is that concurrency in Go was made super easy. So we are in this scenario, right, where we're going to have to basically process a lot of transactions. And we're going to do this on a cloud platform. And we're going to run this in multiple containers for sure. But we want to be able to parallelize easily. We want to get the concurrency easy. And so a Fibonacci generator is quite simple to write in Go. So Go has 2 main concepts. You have coroutines, right? Well, Go routines in Go, which are really, really lightweight threads, basically. You can spin up 1,000 of them, and that's just fine. For Java, that's in Project Loom, if I'm not mistaken, the fibers. That's a similar idea from the Java world. And these coroutines, they communicate through channels. So you have different coroutines running, and there's a channel between them, and they can send data on the channel or receive data from the channel. You can make them buffered, not buffered. You can play around a bit with the settings of these channels. But basically, all data flows through them. So in this case, we have a Fibonacci generator, and the special thing is the arrow syntax. It says we have a channel called C, and X, our result, we push it on the channel. And then we just keep looping. We keep generating Fibonacci numbers. In our main function then, we need to create a channel because we need to have a way of actually communicating. And we say Go. And you can put Go in front of any function. And that function will then not run on the same thread anymore. This function spins up a Go routine. So it's literally one keyword to spin up the routine. And then we can start looping over our channel. And as long as the channel is open, we're going to try to keep receiving data from this channel. So as long as things are being pushed, we keep reading. At some point, the Go routine will close, and at that point, our loop will just exit gracefully, and that's the end of the Go routine. So in Go, we can literally spin up hundreds of these in a second without an issue, right? So that's pretty cool if you want heavy concurrency. I tried to do this in Java as well with the concurrency that was available to me in Java 8. It's quite a bit more code than this. It's a little bit more difficult to reason about. But again, Java is getting very similar system soon. So this was just a decision we made at the time. And then we tell our colleagues, hey, Go has pointers. Isn't that fun? Don't we all remember pointers from C or C++? This stuff, right? That's super fun to read. You know, the right-hand spiral rule, and you have to figure out what your pointer is actually pointing to, and it just becomes a mess. Yeah, so we have that stuff again, but it's not like this. That's one of the pitfalls of Go, perhaps, is that when you say pointers in Go, people think pointers in C or pointers in C++. But they're actually a very, very different implementation of pointers. You do have raw pointers in Go, like the real pointers, but they're in a package called unsafe, because you shouldn't be using C or C++ style pointers. When you're using Go, your pointers are read from left to right. You don't have to start doing the spiral rule and going crazy. Right? Arrays, they're not like pointers. You can't start indexing them like that. So you can't do the pointer arithmetic and suddenly jump out of bounds. Right? And pointers are garbage collected things. Go doesn't do manual memory management. You can do it by the garbage collector. You can tune the garbage collector, but in essence, everything you do will be pushed on that. And there are no garbage values. So if you use a pointer that you didn't initialize, the worst thing is a null pointer exception. That's not great, but it's not a garbage value. And the Go guidelines actually give you some use cases for, hey, when should I be using pointers then? Mutability is the key point here. Right? So by default, if you're not using pointers in Go, it's a completely immutable language. All your structs, can't change them. They're all values on a stack, and they're completely immutable. Immutability is quite a good idea. I'll also add that immutable data structures in Go are going to be faster than the mutable ones with pointers. Right, so people sometimes associate pointers with being fast, but pointers need to be garbage collected in Go. Values don't. Values are stack operations. Push, pop, that's it. But they do say, hey, if part of your functions is going to be mutable, make all of them mutable. Or at least accept the pointer. Because otherwise, the one calling your API constantly needs to be dereferencing the pointer when he needs it. That's just not really a fun way of using an API. Of course, at some point, you're going to be copying large amounts of data. And at that point, we can't say that the pointer isn't a good idea, right? So if you're going to be copying large data structures, the stack will be slower. You will just suffer the relatively small garbage collection cycle, and it will benefit you. As with all performance things, this is something you should measure. There is no magic number. It's multiple kilobytes, megabytes. Just depends. Just measure these things. And sometimes you want to signify real absence. Right? So imagine you're collecting data from students, their exams, and there's a 0 in the set. Is that just a student who didn't study but took the test and failed? Or is this a student who was ill and he didn't take the test, so you shouldn't count this as a data point? So in that case, you will use a null pointer to just signify, hey, this is really absent. I have nothing here. A common case, for example, is the Booleans, right? Booleans, they have true or false, but what if somebody didn't make a choice? That's a nil. Or you could make your own type. And then we have generics. And that's a point that people constantly want to debate, constantly want to argue about, because they're going to miss this when they come from Java. I used to be like this as well. When I was learning Go, I was thinking, okay, how do I make a set of any type? And you can't. Okay, it's kind of a shame. You have no generics. But now, a couple of years later, like 3 years later, I'm actually on the camp that thinks we shouldn't add them to the language. I don't miss them at all. There is not a single moment when I think generics would be good here. Well, there are cases, but there are workarounds in Go. Right? So you have some kind of templating mechanism for the ones who come from C or C++. Like, you can actually create a function for each type using something called the Go generator. But that's a pre-compilation step. So then you first compile the generics and then you compile your actual program. The community is very, very divided about this point. And for the people who really miss generics, there is actually a live proposal that's being implemented called Go contracts. So it's very possible that half a year from now, the next version of Go will actually have this version of generics implemented. At the moment, however, you're stuck without generics. But Go is very batteries included. So we didn't want to use a language where we had to reinvent everything. And Go, as I mentioned earlier, has lots of small programs that we chain together to create a very complex build system. We have a formatter, we've got a module system, we have a linter, which is different than the formatter in that it's usually not a blocking issue. We have testing, so in Java you need to go to test frameworks like unit testing or JUnit. In Go that's provided by the language, and it also benchmarks your code. So no extra installation required. You have documentation tools like Javadoc, and you have Go Please. And Go Please is a language server. And with this, they give any IDE the same functionality. So you can be using Vim with the Go Please plugin, and everything will work just as in IntelliJ or Golang. And on top of that, it's actually a language with quite a huge ecosystem. So that's something that scared us. We were thinking, okay, we're starting with Go. At the time, it was a language of, 7 years old. Are we going to have to reinvent everything? Right? What if we want XML converters or something like that? Well, actually, it turns out there is a pretty huge ecosystem. We go on GitHub, we do a quick search, and we probably find a library. So far, we haven't really run into any case where we had to reinvent something that we thought already should have existed on GitHub. So that's been pretty neat for us. But we did make some mistakes. Right? So even though superficially they might look alike, Java is very much not Go. It is a different language, even though it just looks similar. Another thing is that pointers, like I said, they look like you can just use them to get performance and stuff, but pointers in Go tend to be a bit more tricky. They're not exactly what you think you know from C or C++. So we were like, okay, everything will be a pointer, and everything will be fast. No, it's not. And then you start fixing the pointers, which is hard to do. Another really fun mistake is not starting to use the Go formatter and the Go linter tools when you start your project. So we started doing this about 2 years into our project. We thought, hey, let's run the linter. And we found 4,000 issues. And now we are about half a year later, and we still have 4,000 issues. It's really hard to fix those. You have to go back through your old code, you have to fix all these mistakes, and it's not blocking. So it's really hard to convince people that, hey, this really is going to be an issue. But when you start, in the beginning, it's always a small fix. Documentation that's missing, for example. You can just fix that really easily. And the package structure is different than in Java. So in Java, you tend to subdivide your packages quite a bit, right? So you get a package that has maybe 3 files in them. The HTTP package in Go has more than 50 files in it. And that's fine. There is no reason to keep subdividing your packages. You have packages with a lot of files in them. Test files are in the same package. We don't make a separate package to store test files because they're just normal code. And when you store them in the same package, you get some advantages like being able to use the private methods and test them. So that's something that we really didn't think about that much. We came from Java. We thought we will just learn the language and we'll pretty much use the structure that we're used to. But in Go, you get issues with cyclical dependencies quite easily. And so if you just start doing it without really thinking about your structure, at some point the structure might become an issue. Luckily, by now, since some years ago, Go actually has a nice template that you can look at for how to structure your code, and that has helped quite a bit. So there's a lot in the language, right? And I can't really talk about everything, but some things I do want to mention is that Go has type definitions. So type def phone number is a string, and then you can use phone number everywhere where you would normally expect a string. That just makes the language a bit more type safe, and that's fun to use. You can't push a string where you expect something to look like a phone number. You have named returns, not unique to Go, but it's fun. You can just already declare your output variable at the start in the function declaration, basically. You say, I'm going to return a variable named person, and you can start using that. It doesn't point to null. You can actually start using the variable. But you have different ways of initializing them. So I told you there's no constructor, and that's true. But there are different ways of making it. The syntax with the curly braces is not the only way of creating an object. But they all have slightly different implications. Sometimes if you use one of these initializers, it will point to a null pointer. And sometimes it will not point to a null pointer, but to an empty class. It's just slightly different. You have constants and variables, and constants are real constants in Go. It's not like the final in Java, where you can actually still start changing things on the underlying object. And you have default 0 values. So I'm a huge fan of this. I don't like null pointers. I would avoid using null wherever I can. And Go helps with that. If I have a struct and the struct is not a pointer, it has a default sensible 0 value. For the primitives, that's the same as in Java. An integer is going to be 0. But even your own class will just be a class with empty fields. So if you start using it, you will never run into a null pointer exception. Right? If you use Go in a safe way without using pointers too often, it will be a language where you don't run into that issue. No null pointer exceptions. And Go has its own module system since quite recently. But this is so complex, it probably deserves a talk on its own, right? Just like Maven or Ivy in Java. It's a huge module system, but it's provided by the language. You don't need an external dependency. So that's quite neat. So yeah, people came up to me during this conference and they asked, okay, so but what is it like to learn Go? Is it hard? And honestly, all of you guys, you know Java or a different programming language. You're halfway there, right? The hard part is learning one language, and this looks enough like Java that you're going to pick this up in a week. You're not going to understand it in depth maybe, right? Because that takes years of using it and running into really odd bugs. But you're going to be up to speed in about a week. So we noticed that at work, our colleagues, they pick up Go, they start writing it a week after they pick it up. It's not going to be perfect code, right? But it's going to be functional code. And one of the key points was that Go wants to be readable. And Go is actually quite readable, even for people who haven't seen Go before, who come from another language that's similar, like Java, C#, even C or C++. So we have been using this language for about 3 years now. We're building our system with it. And we love it, right? It gives us so much things like the concurrency. It's fast. It just runs on our Kubernetes containers without any issue, without any overhead. And we just love the language. At this point, we're switching more and more of our Java developers over to Go. As we get more experience, the transition becomes easier and easier. But after 3 years, you've run into so many issues, so many times, that you remember how to solve them. And that makes it easier for other colleagues to learn the language. So next, Go Nuts. That's our IRC channel. So if you want to talk to us on IRC, it still exists. Amazing. You can find us on Freenode. But if you want something a little bit more modern, you can find us on Slack. Or meetups. Go is actually, like I said, it's 10 years old. It's a bit like an underdog language, but it's growing quite rapidly, and you'll probably find a meetup near you. If you're still in Belgium, or if you're from Belgium, the 27th of November is the next one in Leuven. So you can probably find a meetup close to you. So if you want to get started with Go, installing it is quite easy. It's going to GitHub. On Linux and Mac, it's running one line of code. And on Windows, you click next 15 times, and it will also install. And if you don't want to do this, you can go to the website, so play.golang.org. It's a full Golang implementation. You can use GitHub dependencies and everything in there, right? So you can start playing around without installing anything. And you can find me on Twitter, and you can find nexuzhealth on Twitter at those @tags. So yeah, if there are any questions, we still have about 4 minutes left. Yeah. Thanks. You had a question? So the question is if there were any other languages that we were thinking about rather than just Kotlin or going to Go. Yes, so we're Java programmers, so we were thinking, what about just going to a modern version of Java and trying to keep up to date with that a bit more, because we were still using Java 8 at the time. And like I said, we also have Scala, because we have some implementations in Scala. The problem is that we would still be running on a JVM, so that we didn't really want to do. For the front end, we settled on Angular, but we looked at Elm, but way too different. Paradigm shift. So Angular is the choice there. Yeah. Thank you. Okay. Is there any other questions? Yeah?
Given what you know today about the evolution of the Java ecosystem with the Graal VM and things like that, would you still, if you look back, if you were, would you do the same?
So the question is if we would have made the same choice today, given that Java has Graal and all these fancy new features. Probably, right? So the reason is that Go just fits really nicely into our ecosystem as well. We really bought into the Google Cloud ecosystem, and Go is a first-class citizen. So it's a bit more easy. Not to say that we will never use Java applications again, because like I said and like you said, Java is evolving really rapidly, and there's some amazing things going on in the Java community, like Graal. Yeah, thank you. Good question.
If you don't have generics, do you do a lot of casting?
So the question is that if we don't have generics, are we casting a lot? Yes, in some points. We use a lot of reflection in certain parts of our code base, and a lot of casting. But like I said, there are open source projects that basically introduce a generic-like system to Go with code generation. It is code generation, so it's like C++ meta-templating, or templating, however they call it. So yeah, good question.
Don't you have any concerns putting confidential data into the cloud?
Yes, I was expecting this one. Yeah, so do we have any concerns putting the medical data on the cloud? So Google Cloud gets tested quite well. It gets vetted, and the government and other instances think it's okay to store this data on it, and we believe them. They have the certification to prove it. So yeah. Okay. Any other questions? Okay, thank you.